screen. So, okay, are you guys able to see my screen now?
Yeah, Sibbe.
Okay, so since Uzair has already given my introduction, I'll skip that. I'll jump right into the agenda. So, initially, I plan to cover this into three parts. So, one is the blockchain foundation, which is what is the blockchain technology itself, and then create a simple blockchain demo, and then also to basically go over cryptocurrency because without speaking about cryptocurrency, the blockchain is not complete, and then maybe a smart contract. But due to the quantity of the content that we have, I don't want to flood everything in one session, so I'm breaking this into three. So in this session, what we will look at is basically the foundations of blockchain and the core concepts of blockchain. And then what I will also do is I will basically go over a very small demo that is to basically create a simple blockchain. And then we can use that as a foundation to basically build a distributed blockchain or a peer-to-peer network or something like that. So with that said, I will start my session. If you have any questions, please feel free to stop me. Okay.
So, Hasiba, is there a way we can record this session so that we can also have?
I'm already recording this session, so
Oh,
I
awesome!
will, yeah, I
Just
will
okay.
share
Thank
that with you guys. Yeah. Okay, so with that said, so this is the agenda, pretty much what it looks like. So if you are a developer or a business analyst or a program manager or product, manager or project manager, this is for you, the foundation. But if you're a developer, especially if you want to get started, I would recommend some familiarity with Unix, maybe have some familiarity with C++, Java, Python, or JavaScript. So for the sake of this session, I choose to do this blockchain demo in Python, but you can feel free to do it in your own language. The concept remains pretty much same. And then you need to have some familiarity with public keychain infrastructure, cryptography, hash, and how to build REST services and things like that. So since I'm using Python here, I'm using Anaconda, but I think you can use whatever your preferred IDE that you go with. Okay. So let's look at what is blockchain first. Yeah. So the first thing that comes to people's mind when we talk about blockchain is all kind of cryptocurrencies, which would be Bitcoin, Ethereum, Ripple, and all of that. But the hard reality is this is not what blockchain is. So these are the applications of blockchain, or these are things that are built on top of blockchain. So what is a blockchain? That's the fundamental question that we'll try to answer. So if you look at the definition of a blockchain, so blockchain is a growing list of records that is called blocks. So those blocks they are sequentially connected by a chain, and that chain is basically made out of cryptography or some kind of a hash. So that's what blockchain is. So let's try to break this down into two. So one is the block, and then we'll look at the chain. So let's first look at what is a block in a blockchain. Okay. So a block in a blockchain could be anything that can hold data. Okay. So these are the attributes of a block. So the data can also be of any type, meaning it can contain a text document, it can have your property ledger, it can have your title deeds, it can have anything, and or it can have any other multimedia content from videos to audios or something else. And then the other important thing in a block that you will find is called nonce. This is called number at once. So this is a very unique number that is generated or assigned to a block. So generally it's an unsigned integer. So if you are familiar with programming, so an unsigned integer could be anywhere from 0 to 4 billion, or can go beyond in the negative zero or something else. So the nonce doesn't actually work just with an unsigned integer. So this unsigned integer actually works in conjunction with a timestamp. So this together basically comes up with a unique number, and using that unique number, we basically, what we do is we put all of this together, and then we create a unique signature for that block. We call that as hash. So basically what hash is nothing but, so we put all of this into, let's say, you have an apple, you put it in a machine where it gives you juice, right? Apple juice. So we basically put all of this together, and what will happen is basically through a cryptographic algorithm, which is SHA-256, it will give you a unique signature of that block. So there is another thing in a block called previous hash. I just want you to remember this, but we'll talk about this as we go into the next slide. But the basic fundamental of a block, or the basic attributes or properties of a block, are data, number at once, and then the unique signature of the block. So let's say if I have a long text document, or let's say if my name is Hasib Muhammad Afsar, and I store that in a block. So the moment I store that and I generate a hash, I will have a 64 long hexadecimal character. Anytime I go back and change any of my spelling from Hasib Muhammad Afsar to something else, so it's a change to the content. So technically my signature of the block also changes. So this is the very basic building block of blockchain, on which blockchain is built. Okay. Any questions on this so far before I move to? So this is a typical example of a block. So in a blockchain, the first block is called the Genesis block, and then if you look at how the block, or a good example of block is basically it will have like the block number, the nonce, and then the timestamp. And data here could be, as I told you, it could be any transactional data, or it could be any data, like from title deeds to your pictures, to basically even you can have transactional data that you have paid someone XYZ amount, and someone has to pay you some XYZ amount, something like that. So all of these block, nonce, timestamp data, all of these basically put together gives you a unique signature for the block. This is a 64 long hexadecimal character, and anytime you go and change anything here, basically it has an avalanche effect, which will also change the signature of the block. Okay, so that is what a block is. Now let's put this into perspective. Also here, just a side note. So in the data right now that I'm showing you here, when we talk about block Bitcoin, we'll talk about what would be the size of a block, how much content you can store in a block. So the general size of a block in Bitcoin as of today is 1 megabyte. But I will save this conversation for a later point of time. But just as we get started, just keep in mind this is the basic structure of a block. Okay, so now putting this together, how does blocks transition or transform into a blockchain? So as I told you earlier, in blockchain, the first block is called Genesis block. Okay, so as you can see, each block here has a hash, which is a cryptographic signature of itself. So for example, the Genesis block has 2ZB1 something, and here there's something, right? Now these blocks are linked by something called their previous hash. We looked at previous hash. So for example, block 2, so Genesis block will not have previous hash, but the blocks that are added or mined after the Genesis block, what they will have is a property called previous hash. So what this means is that it will basically reference to this block with this hash value. So anytime any content changes here, this hash will change, and the reference that it will do basically will become null and void. A good example would be, let's say you have block 2 and block 3, and in block 2 we have data that is related to transactional data, that I Hasib has to pay Uzair let's say $100. Yeah. Now let's say someone comes in and says there is zero balance in my account, and they basically try to change it. So the moment they change it, as you can see highlighted in the red, this hash value basically also changes. Okay, so now in block 3, basically we are referencing to block 2 based on its hash value. So the moment this happens, the whole blockchain basically becomes null and void. So this is the very basic principle of blockchain. So blockchain basically deals with the integrity of data. So as soon as the integrity of data is changed, you can see that that change is propagated and reflected across the network, and then the system basically kicks in and tries to basically says, hey, this is not what it was, and you have to restore the state. So that is the very foundation of blockchain. I have a paper by these two guys are called the founding fathers of blockchain. So you can find this guy Scott Stornetta in my LinkedIn profile. But also here they have written a paper called "How to Timestamp a Digital Document." So basically, it goes into the details. It's a white paper, so if you're interested, you can take a look at that. But with that said, what I would like to do is I would like to show you whatever I just spoke about right now, how and show you like a demo, real quick demo, and we'll get back to the slides again to put things into perspective. So I'm using this guy here called Anders. So this is a very good material that is written by this guy, Anders. So I'm sorry, someone has a question? Okay. So you can basically go on GitHub and fork this. But let's try to look at first, as I told you, hash. Okay, so here I'm writing my name, and you can see that I get a 64 character of basically my this whole thing in the cryptographic way. So the moment I go and change anything, this hash changes. Okay, so this is the foundation for blockchain. Okay, so this hashing basically is a SHA-256 algorithm. We'll look into that as we go back into the slide, but for the sake of this demo, just understand that anything that goes into the block basically gets converted into a cryptographic unique signature, which is a 64 long hexadecimal character. Now going back to the block, so as I mentioned, so a block will have its number, nonce. So we'll talk about nonce in detail, and here I can have any detail. So for example, let's say I want to have my longest text document. So you can see that this is green now. The moment I copied some text here, the hash changes, and here you can see that this whole block is highlighted in red. It is because that the integrity of this block has been changed. The data integrity or the integrity of the block itself has been changed because the hash has changed. So now if I basically mine this now, or basically try to add this, it's going to take a long, because I think I have a very long text. So let me refresh this and add some very simple text. So so far so good. Are you guys able to follow along? Is there any questions? No? Okay.
So, Hasiba, one question may not be a question, but again, since there's a lot of buzzwords going on where people are investing in cryptocurrencies, and people like me get confused between blockchain and cryptocurrency. So, if you can talk about it for 30 seconds or a minute and you have time in terms of how to differentiate these two, that would be helpful.
Sure. So what I'm showing you here is blockchain. Okay. And so blockchain is basically the underlying technology. So it's like internet. So you can basically use to send messages. You can use to share information. But then that is not itself the Facebook, right? So Facebook basically leverages internet to build that platform. So similarly, blockchain is an underlying technology that products like Bitcoin or Ethereum, they basically leverage that technology, and on top of that they basically add their own protocols to basically have cryptocurrency, which is more transactional. So the difference between blockchain and cryptocurrency is that blockchain is the foundation. Without that, there's no cryptocurrency. Cryptocurrencies are like the applications of blockchain. Does that answer your question?
Yeah, it does. So, how is blockchain considered from a IT governance model? Because you are seeing a lot of talks going on that okay, it is being considered as illegal, or the parliament. I mean, especially the U.S. government want to bring in some kind of guidelines and make it more taxable. So, how is this aligned with the IT industry? Like, will this be another disruptor for next 10 years in terms of how the products are being created for IT market?
Yeah, so there are three potential, not three, but I think more than three. But I can basically tell you right off the bat, there are three potential domains that are going to be leveraging this technology. One is the federal, because I will cover that slide in a bit. So where they have records, they have basically all paper records where they want to digitalize. It's just not about digitalizing them, as day in and day out you hear that there's a lot of hacking that is also going around. So blockchain kind of gives that solution to the problem, not a complete, but it tries to minimize the risk. So from that aspect, yes, blockchain will take a big role as far as in the governance, e-governance. But I think the technology itself is still in its, I would say, not as comprehensively adopted as it should have been, because it's fairly new and it is also evolving. So but it's the right time to basically step in and have a feel of and invest in learning the technology. So in the next, I would say, 2 to 3 years, so that will be a mainstream. I mean, it's already mainstream, but I think you will see a lot of demand that would creep into the market, job market, where blockchain developers are going to be like the hot piece of cake. That makes sense.
Yep, it does. Thank you.
Okay. So coming back to this, so as you can see here, as soon as I enter this, so basically it says that the hash has changed, and it's basically complaining this. Now since I mined this, now you can see there are leading zeros. We'll talk about this. But now after this, if I go and change anything here, yeah, so you can see that it's already changing the hash. Okay, so this is a block. Okay, now going back to the blockchain example, so let's say I added one here, I added
So, Hasib, sorry to interrupt. I think there are certain questions which brothers are asking in the messages. Maybe you would like to have a look.
sure.
Yeah, or you are seeing those messages. Go back to the previous screen. Yeah.
Okay.
So the first question I
Like
think is
doubly,
from
oh yeah, yeah, so it's like it's a I think that's a good analogy. So it's like a linked list, you're right. So what makes hash so expensive? I will cover that into something called so just wait for this, what makes hash so expensive. I will cover that question. I think we're just getting started. So so just bear with me for some more time, and I'll talk about why hashes are so expensive. Okay. So coming back to this, so let's say if I go and add this content, and I basically added this. So now you can see here. So I have this hash, okay, and now I have this previous hash. So the previous hash is basically pointing to this, okay. So anytime I go and change any content here, you can see it's an avalanche effect that this whole blockchain falls apart. Okay, so that is the fundamental of blockchain. Okay, so this is just one single blockchain, but what makes blockchain more powerful is the distributed blockchain. So consider that this is deployed in, I don't know, in India, this is deployed in China, all across the globe. So anyone anywhere else changes it without the approval of any one of these guys, or at least the content here is different from what they are changing, so it will be an avalanche effect, and right off the bat you will notice that this block number 2 is not the right block that needs to be taken care of. So that's what makes blockchain powerful. Okay, so any questions on this before I go back to the slides? Was that clear? What is blockchain? If we have more questions, I think we can talk about that. Without that, I don't think it makes sense for me to move forward.
I I think there's a question from Brother Vase. So, is this a proof of work or proof of consensus?
Proof of work. So in Bitcoin, Bitcoin uses proof of work. So in blockchain, there are two things. One is called proof of work, and then there's another thing called proof of stake. Ethereum uses proof of stake. I will talk about proof of work in a bit. Any other questions, brothers? Okay. If it is not, yeah, I'm more than happy to basically take more questions, but I'll just get back to the slide here again. Okay, so having looked at blockchain, now let's look at the building blocks of blockchain. Okay, so hash cryptography will go into the details. What is a hash cryptography? And someone asked a very good question: why is hash so expensive? We'll also talk about that. We'll also look at what is an immutable ledger, and then we'll also talk about distributed peer-to-peer network. As I just mentioned, the real power of blockchain comes from its distributed network, and then I'll also talk about mining, how it works, and we'll talk in length about mining pools, mining rigs, and stuff like that. And then we can also talk about consensus protocol. So as I told you that anyone anywhere in a network changes something, how is that? How does the network come to a consensus? How does everyone on the blockchain network agree to something that Uzair has $100, or Uzair has spent $10 and his balance is just $90? Now, how does, because everyone is aware of what is his balance in account is. So how does that agreement happen? So we look at that. So, and then lastly, if time permits, I will go over the Python code, where we'll go over like building a simple blockchain. Okay, so first let's look at hash cryptography. So as you know that every person on this earth is born with a unique fingerprint, right? So my fingerprint would be different than yours. Your fingerprint would be different than your children, your mother. So but there is a probability of in 1 in 60 million, or that fingerprint would basically match, but that probability is very very low. It's like it's very very marginal. So what building on this, what the forensics did was that they thought that would be a good paradigm basically to to basically label someone as a unique identifier, or identify someone as unique. So taking that approach, in the computer science world, what we try to do here is similar to a person. What if we have a document which I just showed you, like if I go and enter my name, I get like a unique signature. What if I have a video or like anything just to retain the integrity of the data? So back in the days, NSA, the US National Secret Intelligence Service, basically came up with this algorithm. So this algorithm was not developed by any computer engineer. I mean, of course, he's a computer engineer, but it was primarily used back in those days for more classified information and more in the intel world. So SHA-256, what is SHA-256 is basically, it's a one-way hashing algorithm. So it basically, right now we use that in encrypting database, like storing passwords, encrypting database and all of that. But it's primarily a one-way encrypting algorithm. So what it does is it's 256 bits in memory, so it's 64 characters long. So it's a hexadecimal, meaning so it has 0 1 2 3 9, and then anything after 9 is represented in A B C D E F. Okay, so this combination is what it makes it powerful, because on each bit you can store in each character you can have 4 bits. So if you multiply 64 into 4, that gives you 256 bits. So on the surface, the hashing algorithm, this 64 character may seem easier, To answer that brother's question, why is it makes hashing complex, is because when you try to compress down content down to this hash, it's very, it takes a lot of computational power. And also, this SHA-256 so far is not being compromised, or at least not being broken by anyone. No one has ever broken this cryptographic algorithm. So imagine when you have a distributed network and everyone is trying to basically add a block, and also someone just mentioned about proof of work, which we'll talk about. So proof of work, where you want to have a proof of work before adding a block, you need to basically show to the network that you have mined by solving a mathematical puzzle. That's what it's called, proof of work. So that takes a lot of hashing. You need to find a unique number and its hash, which is the cryptographic equivalent. So that takes a lot of computational power. So GPUs are like the past thing. Now they have something called ASIC, that is even more powerful than GPUs. So that's why you would see that, I think a year back, or maybe a year and a half back, people were going crazy buying GPUs, because when you try to build Bitcoin mines in your home, that requires a lot of computational power. Then your normal computer wouldn't do that. Okay, so you can go in detail and you can basically study how the hash algorithm technically works. It's a detailed white paper. I don't want to go into all the details considering the scope of this session, but I would strongly recommend, if you are interested, you can basically go and look into this. So also, to let you know, Bitcoin, as I said, uses the blockchain protocol. So the blockchain protocol uses they use blockchain protocol version 2, which uses SHA-256. Now they are thinking about moving to version 3, which will be 512, which they haven't done yet, but they are thinking of moving to 512. Okay, just for your information. Any questions on the hashing so far? No? Okay. What is the question here? Okay, is that a comment or a question?
It's a comment.
Okay, okay, okay. Awesome. Okay, let's go back to the slides. Okay, so I'll talk about immutable ledger. So immutable ledger basically goes back to the concept of, you can, when you add content in blockchain or blocks, basically it is immutable. I mean, technically you can change the content. What it tries to illustrate or speak about here is the complexity of changing the content after it is added, or changing the integrity of the content that is being added. So that's what the immutable ledger is. So let's take with a hypothetical example. So let's say you have money, you go and buy a home, right? Then you have a title deed for your home. You basically go to your municipal office or city office, and you try to register this. So this is basically called the traditional ledgers. So traditional ledgers, I'm sure most of you would know and agree with me, even in US in 2009 this has happened. But in India this is pretty common, that people who want to encroach and take charge of your property or land, basically they go and create fake title deeds, right? And then what they do is they basically come up with duplicates, and then they can basically own your home technically. So this is no hypothetical story, but this is actually what is happening as of today. So in blockchain, with smart contracts, or smart ledgers, people try to solve this problem. And how they are trying to solve this problem is, you take a blockchain, so you add a blocks. Basically these blocks could be the records of your neighbors having home, and then let's say you buy a home. So that block basically gets added to the blockchain, and after that a lot of other people basically add or buy new homes, so new blocks get added. Now at some point of time, let's say there is someone who basically wants to take ownership of your home and goes and change that piece of information. What would happen is, going back to our blockchain demo, So the hash of this block would be basically invalid, and that would be propagated all the way to all the other blocks that have been added. So technically what will happen is this blockchain becomes null and void, and whatever this person has changed, he cannot basically own your home until he basically gets hold of the entire network. So this is just single blockchain. We'll talk about distributed blockchain. So here, if it's just a single blockchain, all he needs is time and computational power. And it's a matter of time, when he can do that. But this is just private blockchain. But we'll talk about distributed blockchain, where things become interesting, and this becomes even harder. Okay, so some of the applications of this immutable ledger as of today is that, if you go to the e-governance, they use for birth certificates, title deeds, even for criminal records in prison, diamond sale. So cryptocurrency is basically part of that immutable ledger. Okay, so to answer your question, Uzair bhai, again, so cryptocurrency is just the application of blockchain, but that itself is not the blockchain. Okay.
Okay.
Yeah. So, and also I added this additional reading section. If you guys are interested, this is a very good article. And also, if you're interested in the crypto economics, I would strongly recommend go here and read this. This will give you pretty much good insight into how things works as far as this immutable ledger goes. Okay. So now moving on to the distributed network, just building on that use case. So as I told you, that if he has time and the computational power, if he basically, can mine all other blocks and change all other hashes, so technically you are out of home. So this is where distributed peer-to-peer network comes. So how it works is basically, in the blockchain network, I can join as a node, as a miner, or as someone who does, transaction. So how it works is basically, let's say you have, different systems connected to one another. This could be mining pools, this could be mining rigs, or this could be just a normal user. So what happens is, so let's say if they join to the blockchain network, so whoever joins to that network gets a copy of the entire blockchain. So for example, here in this private blockchain, let's say I have my house title deed. So whoever joins the blockchain network gets this entire copy, meaning they will also see that record of my title deed in their copy. But but here is where the PKI, or the cryptography, kicks in. So they wouldn't be able to relate that to a specific person, because it is all, anonymous based on the cryptographic hash. Okay, but they will have all the records. So let's say someone tries to, buy another new house and adds a title deed to the system. So that basically gets propagated and copied over to all the other systems in the network. And let's say after some point, you have more transactions in the network, and then someone comes along, and then, at somewhere in the network, they try to change that piece of information. So what will happen is, they basically will not be able to, change. They have to basically go back and change every other system that has that copy. So as they are in the process of doing it, what will happen is, all other systems in the network, because they're connected to one another, they will notice that this blockchain in this specific system or node that is connected to the network is not the right blockchain. And what it will do is, the system will automatically, identify that system, and it will basically self heal that system. So this is where, blockchain basically becomes more powerful, especially with distributed blockchain. Distributed peer-to-peer network. So any questions on this?
It's the feature of the blockchains to make fail nodes to be available, or it's the network which takes care of it?
Is the protocol that you implement. For example, Bitcoin may have a different implementation to identify and mitigate the fail node. versus Ethereum will have a different mechanism.
Mm-hmm.
Yeah. So also here, so if you want to compromise the network or if you want to change anything here, right? So there are three critical rules in the blockchain world. So what happens is the longest chain always wins. So for example, if I have added a chain here, which is let's say the first node, and then that chain is propagated to my second node and third node, and someone is trying to add some data, and three nodes have a longest chain. So what will happen is the system will say, I have the most correct data because you can see a consensus from all other three guys. So you have to basically take my data and replicate your chain with mine. So what will happen is, so in this case here, as I showed you that the fail node was compromised and it self healed. So basically all these four systems would see that, and they would kick in and they would say that, hey, look, you got a wrong copy, you need to basically have a right copy, and they will basically push that to that node, and that way basically that node will have the right blockchain again. So in order for anyone to hack the network or take over the network, they need to have something like 51% or more consensus among the network, meaning you need to have access to, let's say you have the Bitcoin cryptocurrency, you want to change something in that Bitcoin world. So you need to have 51% or more control of the Bitcoin network to basically manipulate the Bitcoin. And that is not highly but very unlikely not possible at all, because that's a distributed system, and you have to basically get hold of that system like at one go. It cannot be done like sequentially. So that's what also it makes blockchain more complex. So there's another good article by this guy Vitalik Buterin. So he's the Ethereum co-founder. So I would recommend, if you are interested about decentralization. So this concept just not applies for Bitcoin, sorry, blockchain, but it also applies for a lot of different complex systems. Any questions on distributed peer-to-peer networking before we move on to mining? Any questions, brother? Okay. So if not, oh, sorry.
So I think, sorry, there was a question from Brother Abdul Wasi.
So, brother, I'm making a tangent here. Yeah. So, okay. So why they are? This is because I think so as you see in the network, there's a less, how would I put this? So banks are like the central authority now, right? So they basically regulate this. They basically regulate the monetary inflation. So I think we'll look into that as we go. But they basically set the prices. They set the, like, what's the inflation today, things like that. In the blockchain, or not in the blockchain but also in like Bitcoin, they have something called halving principle. Halving, HAL. I would ask you to take a look at this. I will cover this anyway. This is called the halving principle. And also there's something called the complexity of mining, the blocks. So this is all by the system. It is not by one central authority. So the regulations is basically taken care by the system. So there's no one actually sitting right there regulating this. And the banks basically would like to have that control. I think that's where they're getting very edgy and nervous, because it makes sense for them to basically, that's how they make money, right? So when you have that kind of decentralization, they become very edgy, because that's not what they used to. Does it answer your question? All right. Okay, so going back to the slide. Okay, so distributed peer-to-peer networking. Any questions on this before we move on to mining? Okay, so let's go back to mining. Okay, so mining, as I told you earlier, so we have block and then we have data. Okay, and we looked at hash, previous hash, and all of that. Okay, so now the question is, how do we come up with this hash, right? So this is a $1 million question. So this is what mining is all about. So as I showed you in my previous example, where we are adding the block to the blockchain. So to add a block, you need to have a valid hash that needs to be accepted by the network. Okay. So to generate this hash, there is a certain mechanism and principle that goes behind, and that's what we look into this mining. So how it works is basically, in this top portion, so you cannot change the data, you cannot change the block number, but you can change is the nonce. So as I told you, the nonce is basically the thing called number at once. So whenever you change the number, so basically you're making a change to the entire block. So basically you can, come up with different hashes. So for example, 54, I have a hash here. 32, I have a different hash here. And this number, I have a different hash here. So now you may be asking, okay, what is this to do with changing nonce and getting a different hash? Now, going back to the mathematical puzzle, someone did mention about proof of work and all of that. I will come back to this slide later. I think this slide makes more sense. So when you generate hash, there is something called hash pool. Okay, so the hash pool could start from, just for our layman's understanding, let's say it starts from zero, and my highest number is 10,000. Okay, so zero will have a different, hash. Zero is a decimal number. I think I should have covered this. Zero is so for example, if you have a decimal number like this, when you convert this into a hexadecimal, so this is the hash that you will get. Okay, so zero will have a different hash, one will have a different hash, three will have a different hash, but we're not talking about 0 to 10,000. This number could be, much bigger. So what happens basically is, so the system will tell you that, you need to find a number within a range of 100. Okay, so if you find that, there will be a hash with leading zeros that could be 5, 6, or 18 zeros. And if you find that hash, we will consider that your block is a valid block, and we will add it to our blockchain. That's what the mathematical puzzle is all about, and that's what it's called, the proof of work. So for example, if 0 is here and 10,000 is here, so the the network that you are part of, the blockchain network, the system would say, you need to find a hash that is basically, below 100. It could be, 20, it could be 30, it could be something else. But then when you find that number, the hexadecimal hash, if you try to find that, it should have, you know the same number of leading zeros. Okay, so if it says 4, you should, that hash would, the valid hash would have 4 or 6 or 8 or 18. So Bitcoin, I think, as of today, has like 18 leading zeros. We'll talk about the leading zeros, why it is important, but just building on this concept. So let's say if I change the nonce here to 54, I will have this hash, which is not the right one. For example, let's say if I change this nonce to 22, not the right one. If I change this to 23, not the right one. If I change this to 177, not the right one. And also if I change this to like this one, now let's say this is my actual valid hash, where I see four leading zeros. Then what we call this is the golden nonce in the mining terminology. And what they do is, when as soon as you find this, basically you are now entitled to add this block, and whoever has mined this block get reward in the block, for the block. So in Bitcoin, I think in 2009, when the first block was mined, they would get 50 Bitcoins. Using the halving principle, I think every 4 years, or yeah, 4 years, basically the reward gets half, from 50 to 25. Now it is 12.5 Bitcoin if you mine a block. So now also to answer the question about some time back, someone asked like, why is it hashing so difficult? We just talked about 0 to 10,000 here, right? But as I told you that the number could be pretty big. So you as a miner have to find that number, and then also find the hash that has the the appropriate leading zeros. So the leading zero becomes important because let's say you have this 0 to 99,000, right? So you have 10,000 options. The moment I add 0 here, so now you have to basically work with 9,999 options. Okay, so you all the way come down from 99,000 to 9,000. The moment I add more zeros here, so you will have more less option. So imagine this with huge number, a huge set of number or a huge pool of number, from where you have to find that your appropriate number, and then these zeros are getting added, these leading zeros are getting added, so your options are also getting narrowed down. So if we have to put this in perspective, so let's say your current target, your hash hexadecimal is this, which has 18 zeros. Okay, now let's try to put this in a mathematical perspective. So if you try to understand this, like what's the total possible 64 hexadecimal number that you can have, it is 10 to the power of 77. Okay, now out of that, let's say you want to basically find a hash which is with a leading zero, so you minus 64 minus 18, which is 10 to the power of 25. Okay, so now if we try to put these numbers all into perspective into the probability scenario, the probability of you mining a block is 0.0.0.0.02%. So that requires a lot of computational power, and that's why hashing is very, very expensive. Brothers, I'm sure this is a complex slide. If you guys are like still trying to wrap your head, please let me know. I will go over this again. Okay, no more questions. Okay.
Sorry, can you hear me?
Yeah, I can hear you.
Okay. So, may not be a relevant question, but often discussing with brothers and reading the articles, I think there is some kind of primary key or a unique ID that you need to remember when you are making a purchase of cryptocurrency. If
Yeah,
you lose it,
that is for e-wallets. That is for e-wallets. Yeah, you're right. Go ahead. Sorry.
so yeah, so losing that, it seems you lose your investments, and there are some kind of hackers, I don't know what the terminology is, who keep on looking for mining those kind of lost currencies to make that as their own. So maybe not this session, but in the future session, if you can also focus on some kind of governance policies that we need to follow when if someone is interested to make investment in cryptocurrencies, or how things work, to be more proactive and focus on your investments.
Yeah, sure. I think there's a separate topic on wallets. Sorry, not Bitcoin wallet, cryptocurrency wallets, which I will not be covering in this session. Like as you can see that 45 minutes into it, I'm still talking about the foundation of blockchain. But yeah,
Yep.
definitely we'll talk about that in a separate session.
Because not everyone is as technical as you on blockchain.
Sure, no problem. All right. Any other questions on this? No. I just want to also share some more information with you guys. So, having said the mining difficulty, so I just want to, show you the scale of where this is going. So basically, we with our normal MacBooks or computers cannot compete because on distributed, networks, every miner who is out there, if he mines successfully a block, they're gonna get 12.5 Bitcoin. So they put everything out there basically to make money. Okay, so if you look at from an industrial scale, if you go and basically try to search on eBay or Amazon, you want to basically have like a mining rig setup. you don't need to be technical, but you want to do this as a business, or you want to be like a miner, but you don't want to get into the the technicality, weeds and seeds of things, but you still want to be associated with blockchain and make money. The one way people join is as miners. So what they do is they basically set up mining rigs. So you get this off the shelf from Amazon or from eBay. And what they do is they basically run it at their home. And just keep in mind that I don't know about the U.S. Power, the industrial regulation policy. So if you plan to do it, just make sure that you're not running into the trouble, because in China, they basically have set up like mining pools. So this is in industrial level. So if you look at here, they have like mining pools, and you can just imagine the scale at which they operate. So people basically live there. People basically try to go about working. So it's like you go into a coal mine or gold mine, you try to mine gold, so you stay there, right? So it's pretty much as similar. So they have like dormitories, they have like all of the facilities inside. So basically they work day in and day out just to mine Bitcoin or any kind of other cryptocurrency. So it's people are doing it in pretty large scale, especially with mining pools and mining rigs. But like, let's say if you are an amateur miner, or you want to basically get your feet wet in mining, you can find some pretty basic mining rigs on Amazon, which you can get for $200, $250, and you can see how you feel about it. But this is just more than that, just for your understanding, okay? And also, at some point of time, I was talking about halving principle, right? So in 2009, as I told you, that Bitcoin started with like the $50 for each block. Then it started reducing it. So there is statistics. So as of today, if you look at Bitcoin, because I'm referring to Bitcoin, that's the most popular currency. I could have taken data from Ethereum, but I thought this would make more sense. The number of available blocks is like something like 17 million something, yeah. So bitcoin mining will cease to exist or come to an halt 21 million by 2140. After that, bitcoins, you cannot mine any more bitcoins, because by then they would have solved all the puzzle, as I showed you in that hash pool. So they would have picked all the valid numbers. So after that, there will not be any valid number to basically mine a bitcoin. So after that, how would it work? So this is another tabular data that you can take a look. In 2009, it was $50 if you could mine, and like then it started dropping. So I think in every 4 years it kind of gets into half. So 12.50. So I think by 2020 it will be 3 point something, 2024 I guess. Yeah, I want to talk about this one, actually, monetary inflation and deflationary currency. So we are right now here. If you look at Bitcoin, okay, so basically what happens is, as I told you, 21 million. So the Bitcoin will basically stop. After that, you cannot mine Bitcoin. But the good point about this Bitcoin or the cryptocurrency is that since this currency cannot be injected as you wish, which the central banks does, so there's a principle that is said that kind of aligns or goes back to your intrinsic currency value that we used to in the past with gold and silver and things like that. So what it means is that this currency will not be in excess. Okay, so if there is a, sorry, so it has a stored value. Yeah, so like as I said, if you go back to, I'm sorry, so if you go back to this tabular data which I showed you here. So to begin with, it was 50. You can associate this with $50. Now since the demand is more, the supply is less, it basically last year it shoot up to 17,000. Now it's 3,000. So as there is more demand, I think the currency value would basically go up. So to answer your question about has it a stored value, it has a value, but I think that value is tied to the actual demand and supply. Okay. Yeah, so this is another information that I wanted to share. So bitcoins are getting mined every 10 minutes. So this is the most difficult mining that you can do on Bitcoin. Sorry, on cryptocurrency. Ethereum is 15 seconds, Ripple is 3.5, Litecoin is 2.5. Okay. I just wanted to talk about also the hash and who is using the most power country wise. So if you look at China, as I showed you the Chinese mining pools and rigs, they are the most of the miners that you would see as of today is like from China. And then here's the other distribution, but I think China tops the list. So here on your right, this chart basically is called the hash rate or the hash pool. So who is basically trying to solve that mathematical puzzle? So you can see here from btc.com, which is nothing but Bitcoin. This is also Bitcoin, but there are other players who are also basically trying to mine. This hash pool basically is related to Bitcoin currency. I think for Ethereum it will be different. For the I think Litecoin it will be different, but this is more towards Bitcoin. Who is basically trying to solve and who has most hash power? The mining pools or the mining rigs who have more hash power are likely to mine more coins or likely to get more rewards because of naturally they have more power and they can solve that mathematical puzzle in a very less time. And if you look at the country-wise distribution as far as the power consumption, so this is the global. And if you look at mining, like the amount of power that goes in mining, so you can power Ireland. So Bitcoin mining today across the world, proof of work. So this is where Ethereum is different from Bitcoin. So in Bitcoin proof of work, basically everyone has to solve that puzzle. But in Ethereum proof of stake, the network basically picks who can solve the puzzle. So not everyone can basically put their resources, towards churning more power. So that is one of the challenges also today that with the Bitcoin, because it's very power hungry machines, especially the mining pools. So combined mining power that you have today, Ireland, in fact you can power Ireland with all the mining that people are trying to do. Okay, so that is mining for you. Now I have the last topic, which is the consensus protocol, and then I will jump into the demo. But any questions on mining, brothers?
So, Hasiba, one question.
Mm-hmm.
Now, today's session has a mix of senior brothers and someone who is an OPT. So, is there a word of advice from you if someone who is very new to the IT industry wants to focus on blockchain technologies and make that as a career? If so, what is expected out of that resource to come up to the speed?
Yeah, so I think you need to look at it in two ways. So one is, the first I would say is that you need to have this underlying understanding or the foundation. Basically, programming is one thing, but I think you need to understand how things work, because the intuition is very important. So if someone, especially for the OPT brothers, I would say start with understanding these concepts. And if you're not clear, I would be more than happy to help you out. I can answer those questions. And then once you have an understanding, I think programming and using the tools is just another thing. I don't think it's such a big deal. But I think that's why I'm covering this today, because you need to have a very solid understanding of the very foundation. So if we have that, I think you can build more complex applications on blockchain.
So, since you talk about a very solid foundation, obviously we know how the education system works. So, are there any referential points that these brothers can take
I
back as a
Sure,
task
sure, I
and come
will.
back to you with more guidance?
Yeah, sure. I think at the end of this session, I'm gonna refer some sessions, Udemy sessions, and also I'm gonna refer them some materials that they can take on and go back and kind of do some homework on their own. Which yeah, I would be more than happy to share that.
Jazakallah.
Hmm. Yeah, someone has another question. I saw a lot of questions popping up on Skype. Right. Um,
I think that was for the communication. So, inshallah, as we did last time, we will also send out a communication with the recording that would be stored in Google Drive for referential purposes.
yeah, makes sense. All right, so we'll come to the last part of this, which is a consensus protocol. So consensus protocol, this is a very important concept. It is not just used in blockchain, but it is used in decentralized distributed systems. This is also called the Byzantine generals problem or the Byzantine fault tolerance problem. So how it works is, let's say you have a castle, okay, and then you have four generals who are trying to basically conquer that castle, okay. So now, they have to basically attack at the same time to basically take the castle. So if anyone basically, you know doesn't attack the castle at the same time, or the coordination goes off, then you cannot basically take the castle. So here in this problem, so in this fault tolerance, so how it goes is basically this basically formulates a mechanism for the generals to act instantaneously at the same time. Okay, so that is what it is. So let's say you have a king who sends instruction to the other generals, so all of these three can communicate to one another. Okay, so now let's say this king sends instructions called attack, which is in green. Okay, to this to all of these three guys. So what they have to do is basically they have to basically propagate this, what they got the instruction from the king, to their counterparts, which they would do. So here this guy has done yes attack, this guy has done attack. Okay, now this guy would also do propagate it to the last guy on your right, and let's say he's the traitor, right? So now he says, don't attack. So how they will work is basically they will look at the instruction, or they will come to a consensus. So what they will do is, so here for example, from the king he got the instruction which is to attack, and from here he got instruction to attack, so he got two, and then from here it is one. So the consensus here would be that he would go with the majority. I talked about peer-to-peer networking, sorry, distributed peer-to-peer blockchain, where I said people need to have 51% or more consensus to basically take control of the system. So that works pretty much on this same principle. Okay, so you can see here that there's just one person who has a different opinion, and then 2% say attack, then he would go with attack, and he would go with attack. So this application, or the application of this Byzantine fault tolerance, as I told you, is just not used in blockchain. It is used in aircrafts. So for example, when the aircraft is landing, so you have the landing gears and all of the other hardware. So what they do is basically the system would get data from all the sensors that they have, and they will take basically the majority of data. Or like, if the let's say the landing gear is supposed to be opened up, and it has to land. If let's say you have four sensors that is monitoring whether like landing gear is there, and then one sensor says the landing gear is not open, and then three sensors says the landing is open, so the aircraft system would basically rely on the data to basically make that landing. Okay, the same goes for rockets, so especially for International Space Station. So when we launch a space rocket, so what happens basically is there is a specification that they have to design the rockets in a certain way, meaning when you try to dock the rocket into the International Space Station, so basically they have to comply with the design, and one of the design is this Byzantine fault tolerance. So basically again the same principle goes. So if three sensors data says it is ready to be docked, and the door is open, and then one system says it is not, they would go with that. But if let's say if there is 50% or more that says the doors are not open, you cannot dock, so then it will not dock. So this is like the basic. Even NASA, like your SpaceX, all of those space shuttles that are made today, they basically follow this design in their system. And even nuclear plants, they also follow this. So if anyone is going to have some kind of critical decision that they have to make. So basically they need to have consensus. So that is what it means. And in the blockchain world also, they rely on this principle. So let's say if someone says, ABC John Doe has spent $10, so the network that is 50% or more has to come to a consensus that yes, John Doe has spent $50 and he has, I don't know, $20 in his balance. So if it is less than that, that will not be taken. So that's what Byzantine fault tolerance is, and this is also like one of the building blocks of blockchain. Okay, any questions on this before I jump onto the demo? So these are like the core concepts of blockchain. I would strongly recommend you go back and try to look at this. But if you have any doubts, I would be more than happy to answer your questions. Any questions on this, brother, so far?
Yes, Asif bhai, this is Kaleem. I have a quick question. What happens in case if it is 50% match on in both scenarios?
Yeah, so if it is 50%, I said 50. It has to be more than 51%. You cannot have 50%. It has to be 51% or more.
So in case of plane landing, if it is like if it has four sensors and two sensors says gives green signal to land and two others says do not land, so how does it decide
It will
what to
not.
do?
It will not. That's what I said. Like it has to be either three. That is,
Okay.
it has to be 51 or more. If it is 50-50, it's a stalemate. They will not come to a decision.
Okay.
Yeah. Any other questions? Okay, if it is not, then I will show you a real quick. So as I told you that I'm using Python to basically write this simple blockchain demo. So I use this IDE called Anaconda. So if you are a Python guy, I'm sure you would know this. It's a pretty good one. I strongly recommend this. But if you have a different technology stack, it's totally up to you. You can do the same. So I use. I wish I could write this code alongside with you, but due to the time, I just have this already written for you guys. So here I break this into three parts. So this is also published in my GitHub repo. So you can take this. So one is building the blockchain, okay, and then the other part is basically mining or blockchain. This is creating through the web app, okay. So I will just go over real quick what I'm doing here, and then I will show you a demo. So here I'm importing some basic libraries. Datetime and hashlib is basically what I would use for my hashing, okay. And I use JSON, and Flask is basically a Python web application framework which I'm using. So that's pretty much what I'm doing here. And here I'm creating a class called blockchain, and this is my constructor of my class, okay. So here I create an array called chain, okay. To begin with, this is empty, and then I have this method here called create block, okay. So it takes two parameters. So one is the nonce, and then it takes the previous hash. So to create a block, as I told you earlier, that you need to have a previous. Whenever you create a new block, which is not a Genesis block, Genesis block is the first block, that needs to have a reference to the previous hash. So that's why we basically have this property here where we pass the previous hash, okay. So if you look at the implementation, so it's a simple Python function. So I'm creating a block, I'm having nonce and then previous hash. And if you look at the structure of my block, it's a JSON. So index, timestamp, nonce, we talked about that, previous hash, okay. So what I'm doing, index is nothing but incrementing my index with my the chain plus one. And here timestamp is just from the date time library. Nonce, I'm passing this. We'll look how we'll generate nonce. And then previous hash is this, and then I just add this to my block. So this is a simple function to create a block, okay. Now we'll come to the get previous block. I think most of the people, you would be interested in proof of work. This is what the actual mining is, okay. So if you look at proof of work here, so what I do is, to begin with, first I have a global variable called check proof, which is false. So I go over my hash pool. Okay, so here what I do here is, I have my nonce, I multiply this with 2. So this is my way of keeping the complexity low. So this could be even more or less. I think Bitcoin has a difference, so just don't go by what you see here. Just for the sake of demo, I created this, but I think the complexity you can adjust it. And then once I get this hash, what I'm doing here is I'm having this leading zero. So if I think you remember, as I told you, that if I increase more leading zeros, I'm narrowing down my options. Okay, so if I want to keep the complexity to a minimal, I can keep to 2 zeros or maybe 3 zeros or 4 zeros. Okay, so all of this in blockchain network, in a real-time blockchain network, is adjusted on the go, real time. So like for example in Bitcoin, every 2 weeks or after 2016 blocks, this complexity is adjusted. But for the sake of the demo, I can show you, if I adjust the complexity, how much time it takes when I'm mining a block. Okay, so for now I'll just keep this to like 4. Okay, and then once I have mined the block, I set the flag to true, and then I increase my nonce, and then I return this. Okay, and here what I'm doing is I take the whole block and I return the hash using the Python hash lib, the SHA-256. I'm not doing anything here, no rocket science. Okay, and last but not the least, what I'm doing here is I'm checking the validity of my chain. So how I do it, I go over the complete chain and I check the previous hash of my current block and the hash of my previous block. Is it same or not? And if it is not, then I say it is not. Then that way you basically validate the chain. Okay, so this is what a very simple bare minimal blockchain that you can create. Okay, now once you have created a blockchain, so what I'm doing is I'm creating a web application here, like REST APIs, to basically test out my blockchain. So I use the Python web application framework called Flask, and I instantiate my blockchain class. And here I'm setting the routes basically. So I have one API called mine block, get chain is valid chain, and is valid chain, and then I run it on my local host. So this is my own local name server. So there's nothing called blockchain.hasib but this is just local to me. But you can have whatever you want. Okay, so with that said, let me show you how it works. So I think I'm already running that. So let me stop it and start this again. Okay, so let me start this. So as you can see, it is running here. So I go to my blockchain post requests here. So now let's say when I say get blockchain, so you can see that this is my Genesis block. Okay, so it has index, it has nonce, the previous hash is nothing. So because the Genesis block will not have anything. Okay, so now when I go and say mine block, I have set the mining difficulty to like 4 zeros, but yet you can see that it's taking a bit of time because I don't have those fast powered GPU, even though mine is a Mac. This mathematical puzzle takes a bit. That's why you need more power for your hash. Already my CPUs are going crazy. You can see, I can hear my CPU fans. Someone had a question? Okay. So in this program, property ownership document fits in. So the document ownership property fits in. So I can. So here I haven't added this thing called data. So I can have something called data. Okay, and here I can add anything from a document to something else. So, but I haven't added this because I really don't have anything here. So I just removed this. But you can add anything here. So anyone changes this, so you can see right off the bat, the integrity of your document has changed and the hash will be changed. Does it answer your question? Does it answer your question? Okay. Okay, so as you can see, it's taking a bit. Let me see if I have anything here. Okay, so I'm already running Skype and also um, I think recording video. So my GPU power is like kind of divided. So bear with me for a second, please. Okay, I think I need to stop my video recording and maybe I'll get this back. So you can imagine